Welcome, young detective. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with focus on networking. Also, hit the bell icon to get notified of new videos. Hey there, future secret agent. Today we're going to learn about something super cool called CMAC. It's like a special secret handshake for computers. Imagine you're passing notes in class with your best friend, but you want to make sure nobody changes what you wrote. That's exactly what CMAC does for computers. It's a way to put a special seal on messages so you know they're real and haven't been messed with. Just like how you might use a secret code with your friends, computers use CMAC to keep their messages safe. What's a secret seal? Think about when you get a birthday card from your grandma. She might seal the envelope with a special sticker that breaks if anyone tries to open it before you. That is kind of like what CMAC does. When a computer sends a message, it puts a special seal on it using a secret code that only it and its trusted partner know. If anyone tries to change that message, the seal breaks, and you know something is wrong. It is like having a superpower that lets you detect if someone has tampered with your message. The really cool part is that this seal is created using math, very complicated math that even adults find challenging. But we will make it simple and fun. How does CMAC work? Okay, so here's how CMAC works in a way that's easy to understand. Imagine you have a message, like "Meet me at the playground." Now, you and your friend have a secret word that only you two know. Let's say it's unicorn. CMAC is like taking your message, mixing it with your secret word in a really special way, and creating a magic number at the end. This magic number is the seal. It's made by chopping your message into little pieces, like cutting a sandwich into bite-sized chunks. Then, each chunk gets mixed with the secret word and stirred around. The final mix becomes your seal. When your friend gets the message, they do the same mixing with their copy of the secret word. If they get the same magic number, they know the message is real. Making the magic seal. Let's pretend we are making a CMAC seal step by step, like following a recipe for the world's coolest cookie. First, you need your secret ingredient. That's your secret key, like a password only you and your friend know. Next, you break your message into equal-sized pieces, like cutting a pizza into slices. Then comes the fun part. You start with the first slice and mix it with your secret ingredient in a special blender. The result goes into the next slice, and you blend again. You keep doing this for every slice. For the very last slice, you add an extra special sprinkle. We call these K1 and K2, but think of them as secret sprinkles. After you blend the last slice, you get a final yummy result. That's your CMAC seal. You attach this seal to your message, and off it goes. Checking if it's real. Now imagine you're the friend receiving the message. You got a note that says, "Meet me at the playground," with a seal. But how do you know it's really from your friend and not from someone trying to trick you? Here's what you do. You take the message and make your own seal using the exact same secret word you both share. You follow the same recipe. Cut it into pieces, mix each piece with the secret word, add the special sprinkles at the end. When you're done, you get your own seal. Now comes the super important part. You compare your seal with the seal that came with the message. If they match exactly, like two puzzle pieces fitting perfectly together, then you know the message is real. If even one tiny number is different, you know something's fishy and you shouldn't trust that message. Why chain everything together? You might be wondering, why do we mix each piece with the result from the last piece? That is called chaining, and it is super clever. Imagine you are building a tower with blocks. Each block depends on the one below it. If someone tries to change a block in the middle, the whole tower wobbles and falls. That is exactly what happens with CMAC when we chain everything together. Changing even one tiny bit anywhere in the message makes the whole seal come out completely different. It is like dominoes, tip one and they all fall. This makes CMAC really hard to trick. A bad guy cannot just change one word in your message without messing up the entire seal. It is like the message is protected by a chain of magic that all links together. CMAC versus other secret codes. CMAC is not the only way to protect messages. There is another popular method called HMAC. Think of it like this. CMAC is like building with Lego blocks, representing the cipher part, while HMAC is like building with Play-Doh, representing the hash part. Both can make cool stuff, but they work differently. CMAC is really fast when you have special tools, for example a Lego building robot, and HMAC is fast when you have other tools, for example a Play-Doh extruder. Some computers are better at Lego building, so they use CMAC. Others are better at Play-Doh, so they use HMAC. Both keep your messages safe, just in different ways. It is like choosing between chocolate ice cream and vanilla. Both are yummy, you just pick what you like best or what you have available. What CMAC can and can't do. CMAC is super powerful, but it's important to understand its capabilities and limitations. Think of it like knowing a bicycle is great for riding, but it can't fly. CMAC is very effective at telling you if a message has been changed. Even if someone changes just one letter, CMAC catches it. It also excels at proving the message came from someone who knows the secret word. But here's what CMAC can't do. It can't keep your message secret. Anyone can read it. CMAC only proves it hasn't been changed. If you want to hide what your message says, you need to use encryption, which is a different tool, like putting your message in invisible ink. Also, CMAC can't prove to other people who sent the message, because both you and your friend know the secret word. It's like if you both have the same handwriting, nobody else can tell who wrote the note. Where is CMAC used? CMAC is used in tons of cool places. When your parents use Wi-Fi at home, CMAC might be protecting those invisible internet waves flying through the air. It makes sure nobody is messing with the data going to your computer or tablet. CMAC is also used in cars, yes, real cars. Modern cars have computers inside them that talk to each other. CMAC makes sure nobody sends fake messages to your car's computer saying, "Stop the brakes," or other scary things. It is also used in banks to protect money transfers. When one bank sends money to another bank through the internet, CMAC makes sure the amount is not changed from $10 to $10 million. CMAC even protects satellites in space. When scientists send commands to satellites, they use CMAC to make sure those commands are real and have not been changed by space aliens. Just kidding, but it does protect against hackers. Keeping the secret key safe. Remember how important that secret word is. The entire system depends on it. If a bad guy gets your secret word, they can make fake seals and trick you. So, we need to keep it extremely safe. Think of your secret word as the key to your house. You would not leave it under the doormat where anyone could find it, would you? You would keep it in your pocket or a very safe place. Computers do the same thing with their secret keys. They lock them up in special digital safes, often called key vaults, or they use special chips that are extra secure. They also change these keys regularly, similar to how you might change your password every few months to stay extra safe. And they never, ever write the key down where others can see it. It is like the ultimate secret that needs the ultimate protection. Tricks and traps to avoid. Even though CMAC is super strong, there are some sophisticated techniques people try to use to break it. Let's learn about them so we know how to stay safe. One trick is called a timing attack. Imagine if someone watches how long it takes when checking if cryptographic seals match. Attackers might figure out the real seal by measuring the time taken. So, we have to check seals in a special way that always takes the same amount of time. Another technique is called a replay attack, where someone captures your message and simply sends it again later. This is like someone recording you saying "give me cookies" and playing it back to get more cookies. To stop this, we add special numbers to messages that change each time. The most crucial defense is to keep your secret key secure. Never share it over unencrypted channels, never write it down where others can see, and never use easy-to-guess keys like password 123. Making CMAC super fast. You know how some kids can run really fast naturally, but with the right shoes they can run even faster? That's what happens with CMAC when computers have special helpers. Modern computers have tiny robots inside called AESNI that are specifically built to do the mixing and blending that CMAC needs. It's like having a super-powered blender instead of stirring by hand. When CMAC uses these special helpers, it can be 10 times faster. That's the difference between walking and riding a bike. If you need to check thousands of messages every second, like a big website does, this speed boost is super important. Even without special hardware, programmers can write clever code that makes CMAC faster by doing smart things like preparing ingredients ahead of time or processing multiple messages at once when possible. Speed matters because nobody likes waiting. CMAC in the cloud. You might have heard about the cloud. It is not an actual fluffy cloud in the sky, but huge buildings full of super powerful computers. These computers run apps, store photos, and do all sorts of amazing things. In the cloud, messages are flying everywhere between different computers, and CMAC helps keep them all safe. When you save a drawing to the cloud, CMAC can create a seal to make sure your drawing is not changed by accident or by a bad guy. When apps talk to each other in the cloud, like when your game app checks your score with the score server, CMAC makes sure those messages are real. It is like having millions of secret handshakes happening every second. Cloud computers love CMAC because they have those special hardware helpers we talked about, making everything super fast. It is like a whole city of computers all speaking in secret codes. Testing your CMAC code. When engineers write CMAC code for computers, they have to test it really carefully. It is similar to testing a new bike before riding it down a big hill. They use special test messages that scientists have created. These test messages come with the correct seals already calculated. It is like a math problem where you already know the answer. The programmers run their CMAC code on these test messages and check if they get the same seals. If even one tiny bit is different, something is wrong. They test with all kinds of messages. For example, very short ones, like a message that says just hi, medium ones, long ones, and even empty messages with nothing in them at all. They also test what happens when they change just one letter in a message to make sure the seal comes out completely different. It is like being a detective, making sure everything works perfectly before letting real people use it. The rules and standards. Just like how games have rules so everyone plays the same way, CMAC has official rules too. Really smart scientists and computer experts from around the world got together and wrote down exactly how CMAC should work. These rules are in special documents with fancy names like NISTSP 838B and RFC 4493. These are like instruction manuals that tell programmers exactly how to build CMAC correctly. Having these rules is super important because it means your computer can talk to any other computer in the world using CMAC, and they will understand each other perfectly. It is like everyone learning the same language. Banks, governments, and big companies all follow these same rules. When someone creates a new CMAC program, they can even send it to special testers who check if it follows all the rules correctly and give it a gold star if it does. Other ways to protect messages. CMAC is awesome, but it is not the only superhero in town. There are other cool ways to protect messages too. We already mentioned HMAC, which is like CMAC's cousin. Then there is something called Poly 1305, which is a newer method that is super fast on phones. There is also GCM, which is extra special because it both hides your message and proves it is real, like invisible ink that also has a seal. For some jobs, CMAC is the best choice. For other jobs, one of these other methods might be better. It is like choosing the right tool from a toolbox. You would not use a hammer to screw in a screw, right? If you have a computer with special CMAC hardware, use CMAC if you need to hide your message too. Maybe use GCM if you want something that works everywhere. Use HMAC. The cool part is having choices. Real stories of CMAC in action. Let's hear some real stories about CMAC being a hero. In one story, CMAC protects the computers inside modern cars. Cars today have dozens of computers controlling the engine, brakes, steering, and more. They all talk to each other on a special network. CMAC makes sure nobody can send fake messages like "brake system, turn off." That would be super dangerous. In another story, CMAC protects ATM machines at banks. When you put your card in an ATM, CMAC helps make sure the machine is talking to the real bank computer and not a fake one made by thieves. In space, CMAC protects messages to satellites. Scientists send commands to satellites orbiting Earth, and CMAC makes sure those commands are real. Imagine if someone sent a fake command to move a satellite, it could crash. CMAC keeps our space equipment safe. These real-world uses show just how important CMAC is. The future. Quantum computers. Now, let us talk about something from the future. Quantum computers. These are super advanced computers that work in a completely different way from regular computers. They are so powerful, they could someday break some of the codes we use today. But here is the good news. CMAC is pretty tough, even against quantum computers. The secret keys we use with CMAC just need to be longer, like having a longer password, to stay safe. If we use really long keys, 256 bits, that is like a password with 256 numbers, CMAC should stay safe even when quantum computers become common. Scientists are already preparing for this future. It is like how we prepare for winter by getting warmer clothes before it gets cold. CMAC is ready to keep protecting our messages for many years to come, even in a world with super powerful quantum computers. Your CMAC adventure continues. If you think CMAC is cool and want to learn more, there's a whole world of cybersecurity out there waiting for you. You could learn about encryption, hiding messages, cryptography, secret codes, network security, protecting internet connections, and so much more. Many schools now teach coding and cybersecurity. You could even participate in fun competitions where kids try to solve security puzzles and crack codes, but the good kind where everyone agrees it's a game. Who knows, maybe someday you'll be the one inventing the next CMAC, an even better way to protect messages. Or maybe you'll be protecting important computer systems using CMAC and other tools. The world needs smart, curious kids like you to become the cybersecurity heroes of tomorrow. Every expert started as a beginner, just like you are today. What we learned today. Wow, we've learned so much about CMAC today. Let's remember the most important things. CMAC is like a special seal that proves messages are real and haven't been changed. It works by mixing your message with a secret key in a clever way, piece by piece, creating a magic number at the end. To check if a message is real, you make your own seal and compare it with the one that came with the message. If they match, the message is good. If they don't match, someone tried to trick you. CMAC is used everywhere. In Wi-Fi, cars, banks, satellites, and clouds. The secret key has to stay super safe, or the whole thing doesn't work. CMAC is fast when computers have special helpers, and it will keep working even when super powerful quantum computers arrive. You now know more about CMAC than most adults. Give yourself a high five. Remember, cybersecurity is all about keeping information safe, and you are now part of that important mission. Thank you for your attendance. Please consider subscribing to the channel.